Earth, the only life-sustaining planet in our solar system. Yet throughout its history, our world has been a planetary punching bag.
Anything that crosses the orbit of Earth could one day slam into the Earth.
At this very moment, violent celestial heavyweights roam the universe and threaten to deal the Earth a knockout blow.
The power would be like setting off the whole world's armament at one time. It would be like standing next to Hiroshima all over the world.
Everything in us would get ripped apart, and your body would fly off to infinity.
But some scientists and former astronauts are not willing to go down without a fight. They're racing to track down these cosmic killers before they trigger Armageddon. Earth shimmers like a sapphire jewel in our solar system. We go about our days unaware that in the far reaches of space, trouble could be headed our way.
Our solar system is a lot like an amusement park. Earth and most of the other objects carve predictable paths around the sun. Normally, everything is calm and smooth. But at times, things get chaotic and violent. Earth can be slammed by space rocks, zapped by deadly space weather, jolted, jostled, and threatened by the object's energy and forces of the cosmos.
The Earth is on a cosmic thrill ride, one that often involves extreme danger.
When you're moving fast and on a predetermined path, you hope nothing crosses it because there's nothing you can do.
Nicaraguan border goes right down along.
Former astronaut Rusty Schweikert knows firsthand how dangerous celestial objects can be. In 1969, he piloted the lunar module during the Apollo 9 mission. Now, Schweikert is ready for more than a cruise through the cosmos. He's sounding alarms about the dangers of one particular asteroid named Apophis, which got too close for comfort in 2004.
It immediately got everybody's attention because the probability of impact was quite high. In fact, it was higher than any impact probability that we had ever seen up until that time.
And Schweikert has a terrifying real-life example of just how damaging an impact from an asteroid even smaller than Apophis could be. June 30th, 1908, 7:15 a.m. An object half the size of a football field plunged down from space at around 34,000 miles per hour and produced a stream of fiery gas behind it. Within minutes, the fireball entered our atmosphere and violently exploded above Siberia's Tunguska forest. It became the largest explosion on Earth in modern human history. The blast sparked heat waves, which torched 80 million trees in an area over half the size of Rhode Island. Fortunately, no one died as a direct result of the explosion, because it was in a thinly populated area.
If that asteroid hit just a few hours later, it would not have hit Siberia, it would have hit over Europe. And if that had exploded midair over any of the major cities of Europe, 1 million people would have died like that.
For the last 100 years, the Tunguska explosion has been shrouded in controversy. Today, many scientists agree an asteroid caused the blast. Incredibly, it never even impacted the ground. Rather, it exploded 5 miles above Siberia's frozen ground.
A small stony asteroid can't survive the plunge through Earth's atmosphere. When it smacks into the lower atmosphere, doing about 50,000 miles an hour, it's like an egg smashing onto concrete.
The blast over Siberia released energy equivalent to 15 megatons of TNT, 1,000 times greater than Hiroshima. If this were to happen over a large city, it would annihilate it. Scientists call these trespassers near-Earth objects, or NEOs. They're asteroids and comets, which are leftovers from the formation of the planets. Comets move in the Oort cloud and the Kuiper belt, which is beyond the planet Neptune. Asteroids travel in a band between Jupiter and Mars, but their orbital trip isn't always routine.
Most of the asteroids orbit in a neat belt between Mars and Jupiter, and we don't worry much about those. But when one gets away and all that mass and energy is headed towards Earth, that's when the astronomers start to worry.
Oftentimes, these cosmic remnants get bumped out of their orbit and head on a collision course with Earth. Our planet's thick atmosphere vaporizes the vast majority of them. But a larger object can knock through our atmosphere and actually impact the ground.
If you want to turn to the cosmos and look at the forces that would have us dead, asteroids striking are real and they're bad. It's happened before, it will happen again.
65 million years ago, an asteroid the size of a small city plummeted down from the sky. It exploded in the Yucatan Peninsula near the present-day Mexican village of Chicxulub with the force of 100 million megatons of TNT.
It hits the Earth, cast billions of tons of Earth's crust into the atmosphere, cloaking Earth, blocking out sunlight, knocking out the base of the food chain, and sending a wave of extinction across the tree of life.
It is believed the ferocious impact contributed to the mass extinction of the dinosaur.
We can think of asteroids as being bad things, but were it not for an asteroid, we wouldn't be here today. Our mammal ancestors were running underfoot, trying to avoid being hors d'oeuvres for T-Rex. T-Rex gets taken out. Well, this opened up an ecological niche that allowed our mammal ancestors to evolve to something more ambitious than a rodent. And out comes the primates, and among the primates we have people.
But ironically, the very kind of cosmic boulder that paved the way for humans to exist may one day wipe us off the planet. In 1998, Congress urged NASA to detect all the near-Earth objects over a half-mile in diameter or more. And what they found was unsettling. Over 850 NEOs in our vicinity. These asteroids are our closest and most dangerous neighbors in the solar system. Donald Yeomans heads the NEO program at NASA's Jet Propulsion Laboratory. He and his cosmic bounty hunters search for potential killers lurking in our solar system and put them on their most wanted list.
Finding these near-Earth objects is somewhat akin to tracking hurricanes. As you track it day after day, you get a better idea of its orbit. You can predict where it's going. You have a better idea of how large it is and if it should hit the Earth, with what sort of velocity.
By using telescopic technologies, NASA's Space Guard survey has detected over 90% of all NEOs deemed harmful. These frightening objects could strike the Earth with the energy greater than all the nuclear weapons on our planet today. Such an impact could trigger mass extinction.
You wouldn't expect one to hit but every several 100,000 or millions of years. But if one did hit, it could wipe out a fair fraction of the population. So they're very low probability events, but high consequence events.
If they hit the Earth, they would have global effects. I mean, not only would you wipe out a continent with really heavy shock waves, but the ejecta would be thrown up in the air and come down all around the planet. The atmosphere itself would get to 1,000 degrees or so, and all the vegetation all over the world where that happened would flash into flames.
Cataclysms could also occur with smaller objects. So Congress now asks NASA to locate all NEOs 500 feet in diameter, as wide as the Roman Colosseum. An object that big could decimate a metropolitan area or even a small state. And what worries scientists most is not the asteroids they've discovered, but the ones they have not yet found.
But at any given time, there's about 24 objects for which we can't yet rule out an Earth impact.
Former astronaut Schweikert has taken the threat of NEOs one step further. He's appeared before Congress to request a special government agency be responsible for protecting the public from space rocks.
Today, we have the technology to stop near-Earth objects from impacting the Earth for the rest of history. I mean, we can literally now begin to reshape the local solar system so that our survival is enhanced. The question is, will we? Or will we go the way of the dinosaurs?
But Schweikert isn't waiting for NASA or Congress to solve the problem. He has his own plans to save the planet from the next asteroid impact. It's hard to believe the Earth has survived over 4.5 billion years, because since its infancy, the planet has taken a beating. Like a boxer, our world is under constant assault from asteroids that enter our orbit each year. But in the future, Earth could be knocked out. Former Apollo 9 astronaut Rusty Schweikert refuses to be bullied by asteroids. And now he's ready to defend Earth against these harmful rocks.
We've discovered that there are these near-Earth objects flying by us all the time. And we've gotten more and more capability to modify our environment to enhance our survival.
Schweikert is particularly concerned about an asteroid named 2004 MN4, better known as Apophis. This pockmarked rock, approximately 750 feet in diameter, swept near Earth in 2004. Now it's scheduled to pass dangerously close to our planet again on Friday the 13th in April 2029.
So in 2029, Apophis will come closer to us than our own communication satellites orbiting the Earth. It will be so close that people who are in the right place will be able to see Apophis go by the Earth with your naked eye. You won't even have to have binoculars. That's how close that asteroid is going to come.
Apophis has an over 99% chance of missing the Earth in 2029. But if Apophis passes the Earth at a distance of exactly 18,893 miles, it may pass through a gravitational keyhole, a narrow region in space a half-mile wide. If this happens, the Earth's gravity could upset Apophis and change its trajectory. It could cause it to return and hit Earth 7 years later, on April 13th, 2036.
The gravitational effect of the Earth will cause it to bend, cause the Apophis orbit to enlarge to precisely the size which 7 years later it will come around and hit the Earth.
At the present time, Apophis has a 1 in 45,000 chance of delivering a deadly blow in 2036. But even these odds have scientists placing bets.
It's one thing to know that there's maybe 1 chance in 45,000 that it's going to hit the Earth, but what you'd like to know, is there 1 chance in 100? Is there 1 chance in 10? Is the probability 1 that it's going to hit the Earth?
Schweikert believes we must regard Apophis as we would any natural disaster. He's even mapped out where Apophis might strike.
You have the date of the impact, the time of the impact, the orbital inclination, and you can make a map. And what that map shows is what I have called a path of risk that goes all the way across the planet. And I look at this and I see a high probability of impact and I say, whoa, where might it hit?
According to Schweikert, Apophis could impact any point along this path of risk. It begins in western Siberia, cuts across and down the Pacific Ocean near California, then it traverses Central America and finishes in Western Africa. Schweikert proposes a chilling scenario of where Apophis might strike. The asteroid could land in the Pacific Ocean off the coast of California with the force of over 1 million megatons of TNT. Such an impact would create a 5-mile wide, 9,000-foot deep crater in the water, which would unleash tsunamis. Relentless 50-foot waves would pound the coastline, resulting in unimaginable human loss.
An asteroid that's 1,000 feet in diameter, having it hit in the ocean is not a good deal. Hundreds of billions of dollars of damage from something like that.
Scientists are presently working on technologies to preempt such a cosmic strike. One idea involves blowing up an asteroid. But some feel this could compound the problem, sending several chunks of the asteroid in our direction instead of just one. Consequently, Schweikert's new mission is to change the orbit of asteroids that could impact Earth.
What you want to do is basically change the asteroid's orbit very, very slightly. You change its velocity by a 10,000th of a mile per hour so that it will miss the Earth instead of hitting it.
Rusty's colleagues have drafted conceptual designs of spacecraft that could deflect asteroids, particularly Apophis. One would tow harmful asteroids away from Earth, but instead of lassoing the rock like a bull in a rodeo, the tractor will hover in front of it and use gravity as a tow line.
If you park in front of an asteroid for a long enough period of time and you stay close enough to it but not touching it, you're going to increase its velocity. Or if you park behind it while it's moving along, you're going to slow it down very slightly. We can change the orbit of an asteroid if we know about it far enough ahead of time.
Although a space probe has landed on an asteroid in the past, the most challenging idea is launching a manned mission. Once landing on the rock, astronauts could mount a radio transponder to track its whereabouts.
You could just use a robotic mission to go to an asteroid, land, grab a sample, and bring it back. That's not that difficult. What you gain by a manned mission is they can react to interesting areas on the asteroid surface. They could go here, there, and they wouldn't have to rely on remote navigation.
Nicaraguan border.
Schweikert insists we should remain on high alert regarding asteroid Apophis, and his cause hasn't gone unheard. Now the United Nations plans to draft a treaty which will include who will be responsible for deflecting killer asteroids.
That would be a real crime if we are so irresponsible, knowing that this is going to happen, that we continue to do nothing about it.
But asteroids and comets are not the only deep space threats.
Earth has had its ups, and Earth has had its downs. We never know what's going to be around the next corner, and a lot of it is bad.
In far-off galaxies, galactic invaders are at work, itching to end life on the planet as we know it. 3 times daily, a strange flash pulsates across our sky. It's hundreds of times more powerful than the world's total nuclear armament, but it's not man-made. And if one happens close enough to Earth, it could end life on our planet. Most Earthlings are unaware of the potential hazards in space, but the list is long and growing. Imagine this. Within our own galaxy, the Milky Way, a massive star explodes, sending a lethal burst of energy rocketing toward our planet. This is a gamma-ray burst, the biggest explosion to rock the universe since the Big Bang. In the cities and countryside below, there's no warning of what's about to happen. And then, it strikes.
It would be equivalent to standing 1 mile away from Hiroshima, any place on the Earth.
The potent radiation cooks the upper atmosphere. Our ozone layer roasts. Across the hemisphere, human beings burn to death from radiation 100 times the fatal dose. The disappearing ozone layer causes increased temperatures around the world, triggering cyclones, tsunamis, and hurricanes. Most life on the surfaces of land and water incinerates. This may seem like science fiction, but it could happen if a gamma-ray burst hit Earth from 100 light years away.
Gamma-ray bursts are the brightest explosions in the universe. Because they're so far away and yet still so brilliant, they must involve an enormous amount of power. As much energy as the sun will emit in its entire 10 billion year lifetime.
As a young student, Stan Woosley always liked experiments that go boom. Now, the work of this astrophysicist is more than child's play. He's one of the galactic detectives trying to uncover the mysteries behind gamma-ray bursts.
We know there are many planets and many stars throughout the cosmos, so there may have been countless civilizations that were destroyed by gamma-ray bursts.
These peculiar beams of radiation were first spotted in the 1960s. At first, most astronomers believed these gamma-ray bursts must exist in our own galaxy, the Milky Way, because they're so bright.
There were reasons for that. One was that if they were outside the galaxy, the energy was almost unbelievable.
But at the time, even the most powerful telescopes couldn't determine their location and distance, because the bursts lasted for a few seconds, then disappeared. But then astronomers wondered, what about their afterglow? Cosmic explosions typically leave behind some luminous residue that sometimes lasts for days or weeks. In the late 1990s, satellites used upgraded optics and X-ray detectors to finally capture a gamma-ray burst's afterglow.
It became clear that gamma-ray bursts actually were cosmological, coming from very far outside of our galaxy, from millions and billions of light years away. And that meant their energy had to truly be astronomical.
To get some idea of how incredibly bright a gamma-ray burst is, we could represent the brightness of our sun by this relatively dim LED, and we could represent the brightness of the gamma-ray burst by the very, very intense searchlight that's behind me. Isn't that incredibly bright? Unfortunately, with this comparison, the searchlight is not nearly bright enough to represent fully the gamma-ray burst, and in fact we would need 100 billion such searchlights to have an adequate comparison. The gamma-ray burst is equivalent to the brightness of 1,000,000 trillion suns.
These massive bursts could decimate Earth. But what causes them?
We are quite convinced that the common gamma-ray burst comes from the death of a massive star, at least 10 times the mass of the Sun. And such stars are quite rare, by the way.
Woosley masterminded a groundbreaking model of how gamma-ray bursts may be created. When an extremely massive star dies, it collapses into a black hole. Black holes are created when a collection of matter collapses to such a high density that light itself cannot escape. But Woosley proposes that some of the star resists getting sucked into the center of the black hole. As a result, a high-speed spinning disk of matter forms around it. Within seconds, jets of plasma shoot out from its rotational poles. These beams of energy unleash dangerous gamma rays into space.
If you can imagine just trying to squeeze a fruit or some kind of sphere of some object into a very small space, things are going to squirt out. And in this case, the squeezing is done very rapidly, and you're talking about a huge amount of mass.
At the same time the gamma ray bursts are ejected, the collapsing star explodes or goes supernova to the extreme.
One of the reasons gamma-ray bursts are so incredibly bright is that they take an enormous amount of power and then they focus that power into a very small portion of the sky. For every 300 gamma-ray bursts that go off, only one is pointed in our direction, and so we only see one of those 300.
Even if a gamma-ray burst were to occur not 100 but 1,000 light years away, the Earth could still face apocalyptic destruction.
If a gamma-ray burst happened within 1,000 light years of the Earth, then it would be approximately 500 times brighter than the Sun and emitting gamma rays. The energy delivered to the Earth's upper atmosphere would be like 100,000 megatons of nuclear explosions. The ozone would be depleted. We'd have acid rain, but we'd also have flash burns, incineration of vegetation, perhaps something resembling nuclear winter. So there could be a global extinction of many species. Now, the far side of the Earth would be a special place to be, because gamma rays don't go through the Earth, and if you were on the other side, you wouldn't get flash burned. But the effects of depleting the ozone and changing the composition of the atmosphere would eventually come to the other side, and there the effects are unknown.
Statistically, this ghastly scenario has a 1% chance of happening once in the Earth's entire lifetime. But even these odds aren't reassuring if you're living on the planet at that very moment.
If you're caught in the beam, that's a bad day for you. If one of these happens in your galaxy and that beam is coming your way, go hide in a cave, because this is very high energy radiation. It's the kind of energy that will decompose your molecules, and you just don't want to be around when that's happening.
There currently are no defense measures to shield us from gamma-ray bursts if they happen close to Earth. They travel at the speed of light, 186,000 miles per second. By the time we detect them, they will have already struck our planet.
Gamma ray bursts could pose a hazard to the Earth or to anything living that came within their bore site. But as we've seen, they're very infrequent. And there are other things in the heavens and on the Earth that are much more dangerous.
Cataclysms routinely erupt in some corner of the universe. And one day, something will snuff out Earth.
Most of the time, our ride around the sun is gentle and uneventful like this Ferris wheel. And as long as nothing gets in our way, we could go on like this for millions of years. But sooner or later, we know that this smooth ride will come to an end. We just don't know when.
Sadly, our planet's ultimate demise will probably come from the very thing that provides us life. Earth maintains a cozy lifestyle, being third rock from the sun. For over 4 billion years, the sun has been an ally, warming and feeding our planet. But in time, our solar heater will become our enemy.
The sun and the Earth have a unique relationship to each other. The Earth has a particular temperature, it's a particular size, it has life on it, and oceans, and those things depend on the sun. The sun is at the root of the existence of life on the Earth, and the sun will be at the root of its demise as well.
Earth's relationship with the sun will become dysfunctional when our solar mother really turns up the heat.
The sun gets hotter because it's burning hydrogen into helium. 4 hydrogen atoms become 1 helium atom. That means there are fewer particles bouncing around inside the sun. And that process basically means that the sun has to get hotter and brighter to hold itself up.
As the sun's core gets hotter, its outer parts will swell in size and turn red.
If you have a bonfire, you have all this wood there, and you build it up, and at some point enough logs get burnt and the thing collapses and you get this huge burst of sparks and it gets much brighter. In a sense it's like that because the sun is right now burning hydrogen to helium, and the helium is the ash of that, if you like. And then as the sun collapses enough, the ash relights and the helium burns into carbon. And that's when things get really hot.
At this point, the sun will expand into a red giant and incinerate most complex life on Earth.
When the sun becomes a red giant, it will grow to 30 times its size. So the surface of the sun will actually be out beyond the orbit of Mercury. The luminosity of the sun will go up by like 1,000 times. And that's going to make the Earth so hot that the outer crust, the rocks, the solid part of the Earth, will melt. The whole planet would be a glowing ball of lava.
The sun will fry the inner planets, and even though the sun will become red and cooler, the Earth will be much hotter. Just leave the Earth a burnt cinder, like a charcoal briquette. So that would be bad for life on Earth.
And the Earth's hellish fate isn't over. As a red giant, the sun will fluctuate in size before collapsing into a white dwarf.
The sun that was huge suddenly becomes the sun that's very small and extremely dense. It's only about the size of the Earth, sitting down there at the center of our solar system, very much fainter than it used to be, and then everything cools off. And then that object is no longer generating energy either, so it begins to cool as well. So the final fate of the solar system will be to cool off and freeze.
Humans will probably have relocated to another planet or become extinct before the sun turns Earth into a snowball. However, the sun may dry up our world much sooner.
If the sun doesn't get us at the time of the red giant phase, It may well get us earlier by just becoming bright enough to cause the oceans to evaporate. Water is an essential component for all life. And so if the Earth actually loses all its water, then that's another reason why life might disappear from the Earth, and it would again be the sun's fault.
There may be ways for Earth to win a stay of execution.
As the sun is swelling, it also begins to lose mass much more rapidly than it's losing it now. And of course, if it's getting less massive, it has less of a hold on the Earth will move further out into a larger orbit. And so it's kind of a race between the growing sun and the growing heat from the sun and the Earth actually moving, a little bit away from that fire that's getting too hot.
If our planet somehow manages to avoid getting fried or frozen by the sun, its future remains increasingly bleak.
This place is full of adventure. Rides that put your stomach up into your throat, things that collide, scary stuff. It's a lot like riding around the sun on planet Earth. But when Earth gets smacked or when things start to come apart, the ride could really be over.
I don't know what that means for the universe to end, because I like time. I live in it. So it's hard to imagine time ending.
Today, scientists contemplate our inevitable fate. In the distant future, the Earth and the entire universe may face the ultimate cosmic monster. No one suspects that Earth's most lethal enemy lurks amongst the stars. But in the future, and without prior warning, a cosmic Grim Reaper will unleash the ultimate Armageddon. The dark villain will stretch apart the universe. Galaxies themselves will split apart. Stars and planets will tear to shreds. The ultimate apocalyptic event is being called the Big Rip. And when it begins, it won't stop until every atom and nuclei in the universe are mincemeat.
The Big Rip, it really is the end of the universe. It's not like we're the last ones at the party wondering what's going on and we can go do something else. It's really like you've turned off all the lights and the universe just ends.
Innovative physicists Robert Caldwell and Mark Kamiankowski proposed the notion of the Big Rip, a grim hypothesis about the final fate of the universe.
We used to think that the universe, which is currently expanding, could reach a point of maximum expansion. The Big Rip is the idea that the expansion will not only continue and accelerate, but rip everything apart as it does so.
Caldwell and Kamiankowski calculated that the universe is expanding at an alarming and increasing pace, and that something is sucking everything outward like a vacuum. Acting like a galactic vice squad, these young scientists hunt for the cosmic killer. They believe a mysterious phenomenon called dark energy may be the culprit.
Figuring out what dark energy is probably the #1 goal of cosmologists today. Dark energy is dark, so you can't see it. We can feel what it is. We feel it through its effects on the gravitational behavior of the universe. There could be some dark energy in this room, under the chair. It's only when you look at its properties on really big cosmological length scales, billions of light years across, that you start to see the cumulative effects of the dark energy. It causes things to be pushed farther away from each other and contributes to the expansion of the universe in a quickening pace.
Edwin Hubble, whom the Hubble telescope is named after, first discovered the universe is expanding back in the 1920s. But it wasn't until 1998 when a crack team of scientists measured that this expansion is moving like a runaway train.
A nice analogy is to imagine that the universe, our three-dimensional space, is like the surface of a rubber balloon that I'm blowing up. Okay, I'm going to blow up the balloon as a demonstration of the effects of the expansion of the universe. As the balloon gets bigger, that's the depiction of the expansion of galaxies.
There's galaxy. Another one.
Where's our galaxy?
Okay. We live there.
Okay, that's our home. As the universe expands, every other galaxy gets farther away from us.
In ordinary expansion, each galaxy stays the same size. But if you have super accelerated expansion, then the galaxies themselves can each expand, which is sort of what's happened here.
If I could blow it up fast enough to depict a big rip, then the balloon would explode. That's like space-time not being able to take it and coming to an end. So instead we'll just pop a hole in the balloon. That's the big rip.
According to Caldwell and Kamiankowski, the universe has no hope of surviving the Big Rip. They've even come up with a countdown to this apocalyptic event.
The Big Rip kind of rolls up its sleeves and progressively takes apart the universe layer by layer, working from the outside in, going from the largest scales to the smallest scales. 1 billion years to pull apart clusters of galaxies, then hundreds of millions of years to pull apart galaxies themselves, and then down to the size of a solar system, we're talking hundreds of thousands of years, and then to tear apart the Earth itself would take less than an hour. It's kind of interesting to think about what that would look like. If I'm in my protective capsule watching things happen, I would see this wall of darkness that starts coming towards us. I would no longer, at that point, be able to see any stars. The Earth, layer by layer, will be peeled off and ejected away.
Everything in us, the molecules that hold us together, would get ripped apart, and every atom that makes up your body would fly off to infinity in a very short period of time.
Fortunately, mankind doesn't need to lose sleep over the Big Rip. Caldwell and Kamiankowski estimate that it will climax 50 billion years from now, when the universe is over 3 times its current age.
What's really fun for us is to try to figure out whether this is actually what's going to happen, to paint the science fiction scenario of what might happen and to think what might happen to us.
Deep space threats are real. Some could harm us tomorrow, others in the far future. But one thing's certain, something will terminate Earth and probably the entire universe once and for all. It's only a matter of time.
It's useful to sometimes think about how fragile our life is here on Earth, that maybe we aren't going to be here for eternity. Maybe there's a hope, but the way it looks, the universe just ends, and that's it.